All right, so we're just looking at solving equations. So we have 3x plus 7 equal to 13. Your goal is to get x by itself, or whatever variable you're dealing with. You want to get that by itself. So you want to undo what's being done to it. So we have 3 times x plus 7 equal to 13. So the most efficient move is to subtract 7. And remember, your goal is to get x by itself, so whatever's being done to x, that's what we're trying to move. We want to move that thing away from x and let x be on one side by itself. So we're going to subtract the 7. And your equation is split up into two sides. You got your left side and right side of the equal sign. So we're going to subtract 7 from both sides of the equation in order to keep the equivalency. 7's cancel on the left. So that'd be 3x. And then on the right, 13 minus 7 is 6. All right, and then from here, we have 3 times x, so we want to divide both sides by 3. 3's cancel. Solution is x equal to 2. All right. Questions? Any questions? All right, here we have our variable on two different sides of the equation. 6x minus 4 equal to 6x minus 8. I said 6x, 2x minus 8. We have our variable in two different places. So your goal should be to get all of your variables with x on one side of the equation and all your variables without x to the other side. All right. Doesn't matter which term you move first. You got 6x, negative 4, 2x, negative 8. Doesn't matter which one you move first, as long as you stay correct with your mathematics. So 2x, if I subtract it from both sides, will cancel out on the right. 6x minus 2x is 4x. Minus 4 equal to negative 8. Now I will add 4 to both sides. Notice we're doing the opposite operations to undo what was being done. So I had to subtract 4, so I'm going to add 4 to both sides. They cancel on the left. Leave you with 4x equal to negative 4. And we can finish this all by dividing by 4. 4's cancel on the left, leaving me with x. And then on the right, negative 1. All right, questions? Any questions? All right, so we have 2 plus 7x minus 5 equal to 6 times the quantity of x plus 3 plus 2x. So we need access to all of our x terms, so I will go ahead and distribute this 6. So that's 2 plus 7x minus 5, 6x plus 18 plus 2x. Now we have terms that we can combine on both sides of our equation. So simplify this side as much as possible. Simplify this side as much as possible before you move terms across your equal sign. So on the left side, we have 2 and negative 5. So that would be 7x minus 3. On the right side, we have 6x and 2x. That'd be 8x plus 18. Make sure we're okay before I go any further. All right. So now I want to get all of these terms to one side, all of my terms without x to the other. So if I subtract 8x from both sides of the equation, they cancel on the right. On the left, I have negative x minus 3 equal to 18. I add 3 to both sides. Negative x is equal to 21. And remember, you're solving for x, not negative x. So that negative, you can take it to the other side. And the result is x equal to negative 21. Equal to 4x minus 5 times x plus 2 minus 6. All right, so we want to get rid of these parentheses that we have. So we want to distribute this negative and distribute this negative 5. So there's 9 minus x plus 3 plus 4x equal to 4x minus 5x minus 10 minus 6. All right. Any questions? So just like before, you want to simplify as much as you can on the left side of your equation. Simplify as much as you can on the right side of your equation. So on the left side, you have 9 and 3, which is 12. And you have negative x and a positive 4x, which is positive 3. Somebody said something. Let me get there. Hold on. Can't see anything. All right, let me see what's going on. Y'all say y'all can't see anything. Hold on. Not sure why not. It's supposed to be sharing. All right, I stopped it, and let's see if I can get it back. All right, can you see it now? Anybody? Okay. I don't know what happened. Cool. As long as you guys can see it now. I don't know. I never stopped it from sharing. Okay, cool, cool, cool. Thank you. Thank you for letting me know. All right, so let's go back. Um, I'm assuming the sharing stopped when we started this new problem. Do I need to go back or are we good? All right. So I don't know how far I need to go back. Well, this was the second to last problem. So here all we did was we distributed 6 into the parentheses first. That gave us 6x plus 18 plus 2x. Then we combined our like terms on each side. So 2 plus the negative 5 gave me a negative 3. So that's 7x minus 3 right here. And then we had 2x plus 6x gave me the 8x plus 18. If I can erase. Let me erase now. All right, so this is what we had after we combined our like terms. Then I decided to subtract 8x from both sides. And that canceled out my 8x on the right, leaving me with negative x minus 3 equal to 18. Then to finish it off, I added 3 to both sides. 3's cancel on the left, leave me with negative x equal to 21. Then to get the negative off of x, you send the negative to the other side. So x is equal to negative 21. All right. So that's when we got here. We have 9 minus the quantity of x minus 3 plus 4x equal to 4x minus 5 times the quantity of x plus 2 minus 6. And so we distributed the negative first and then distribute negative 5. So it gave us 9 minus x plus 3 plus 4x. Then 4x minus 5x minus 10 minus 6. And so what I was saying is that you need to combine like terms on both sides of your equation. Just like before we look to move terms across the equal sign. All right. So I added 4x and negative 3x, negative x, excuse me, and got 3x. And 9 plus 3 gave me 12. Then on this right side, we're looking at 4x and negative 5x, which is negative x. And then negative 10 and negative 6, which is negative 16. All right. Questions? Any questions? All right. So now, once again, I have variables on both sides of my equation. So I just need to decide which one I want to move first. Take that to the other side. So that's 12 plus 4x equal to negative 16. Subtract 12. 4x is equal to negative 48. divide by 4. Fours cancel on the left, but on the right you have negative 12 as an answer. I'll put 48. It's supposed to be 28, isn't it? Put that 48 strong. So it should be a 7. Negative 7 for the answer. All right, questions. All right. So 2 more scenarios. You know what? Before I say just 2, I need to do at least 1 or 2 with fractions. Hold on 1 second. All right, so here we'll distribute. That'll give us 2x minus 8 equal to 2x minus 7. Now, if I decide to solve by subtracting 2x from both sides, notice that variables cancel on the left, but they also cancel on the right. So a lot of times people are afraid to let the variables cancel on both sides. But if 2x minus 2x cancels on the left, then 2x minus 2x also cancels on the right as well. And so what you're left with is negative 8 equal to negative 7, which is a false statement. Now, that's not your answer, but that's what ended up happening. So, two things happen here. If your variables cancel and you end up with a false statement, your answer is no solution. All right, here, distribute 2. We have 4x minus 5 equal to 2 times the quantity of 2x minus 3 plus 1. So if you distribute that's 2, it's 4x minus 5 equal to 4x minus 6 plus 1. Combine these like terms in the back. 4x minus 5, 4x minus 5. Subtract 4x. Notice they cancel on both sides, just like last time. But this time, we have a true statement. So if you end up with a true statement, then it means your answer would be all real numbers. So in the last one, no solution, that means no values you can plug in to make that a true statement. And then for the last one we just did, no matter what you plug in for x, that will be a true statement, or in other words, it will work. Questions on those two? Okay, cool. All right, so I want to make sure I talk about fractions before we leave it. So here we have 5, 6x. I guess that one's okay. Should have did another one. Anyway, 5, 6x minus 3/4 equal to 1/3. So we can work with this one or two ways, or solve it one or two ways. Either we can keep the fractions, or we can do what we call clear out the fractions. In which that's what we're going to do right now. So first thing you want to do is find the LCD. When you look at 6, 4, and 3, you want the smallest number that 6, 4, and 3 can divide into evenly, and that is 12. So we're going to multiply each numerator by the LCD. Notice I said each numerator. We're not multiplying numerator and denominator, just each numerator. We're multiplying across the equation. So we multiply each numerator by the 12. And even if you didn't find a complete LCD, let's say you saw 24, as long as each denominator can divide into that number evenly, then you're still fine. LCD is just the smallest number to work with, but whatever, as long as the number that you multiply to each term is divisible by the denominator. So we have 6, 4, and 3. Whatever number I multiply by each numerator has to be divisible by 6, 4, and 3. So let's say simplify. So next step is to go ahead and simplify. just going to rewrite this here. So 6 goes into 12, leaves you with 2. 4 goes into 12, leaves you with 3. 3 goes into 12, leaves you with 4. So that's 2 times 5x minus 3 times 3 equal to 4 times 1. 10x minus 9 equal to 4. Now we have a regular linear equation. And so the last step is to just solve. So adding 9 to both sides, that'll be 10x equal to 13. Divide by 10. 10's cancel. X is equal to 13 over 10. All right, so we have x minus 2 over 5 equal to x minus 4 over 2 equal to 2. So follow the same steps. We have this 5 and 2 in our denominator. We need to get rid of them. First step is to find the LCD, which is 10. That's the smallest number that both 5 and 2 can divide into evenly. Second step, we're going to multiply that 10 to each numerator. Not going to distribute it. Just leave it outside. And even if it doesn't have a denominator, multiply by 10. So everything needs to be affected by the 10 or you will be changing the value of the equation. All right, so now I'm going to simplify. This 5 goes into 10, leaves you with 2. 2 goes in 10, leaves you with 5. So I didn't distribute, just want to make sure we were clear with what reduced and simplified. So that's 2 times x minus 2 minus 5 times x minus 4 equal to 20. So step 4 is to go ahead and solve. So I'll go ahead and distribute. Maybe 2x minus 4 minus 5x minus 20 equal to 20. Combine your like terms. So 2x minus 5x is negative 3x. Negative 4 over negative 20 is negative 24. me see, looking back, -5. Oh, that should be a positive 20. So that would change that. That's going to be a positive 16. Sorry about that. Looking at my signs, I saw I messed up one. So that -5 times x is -5x, with -5 times -4 is positive 20. So then combining positive 20 with that -4 would give me a positive 16. Subtract 16 from both sides. -3 is equal, or not -3, -3x is equal to 4. Divide by -3. X is equal to -4/3. Questions? Any questions? All right, so in chapter 10, we have 2 more sections to talk about. So on last Thursday, no, we had I sent you videos on these problems, these type of problems, and so you were supposed to check these videos out, or those videos out that I sent. And I was just doing a review on those type of problems that we supposed to have done Thursday through those videos. All right, so we got 10.4 and 10.8 to do out of chapter 10. What y'all want to do? Y'all want to do 10.4 today or save it for next class? Somebody said today. Knock it out. Doesn't matter. Oh, okay. All right, sounds good to me. So we can do 10.4 today, and then we'll only do 10.8 next class. So we only have one section to do next class. All right. So sounds good. Sounds good. All right. So we got 10.4. So we got applications. Just a few small word problems, and then that'll be it. I'm actually surprised. Most people would say, no, next class. Uh, Trying to act like y'all G's in here or something. So -11 is... All right, so the sum of a number and -11 is 15. Find the number. All right. So when we have something like this, they're going to be keywords. That's going to let you know what to do. Keyword here is the sum. That means addition. So the sum of a number and -11. So the number is just any variable. Call it what you like. All right. So x plus -11 is the sum of a number and -11. Is equals and 15. So that's your equation. So from here, we can go ahead and solve. Add 11 to both sides. Okay. Yeah. X is equal to 26. All right. Problems with that one before we look at another one. Also, I could have put down the steps of problem solving. Since we're about to do a few more, I can go ahead and do that now. So, of course, yeah. All right. So, you want to read the equation or read the problem, make sure you completely understand what they're asking of you. You want to assign variables to each unknown. And let me see if they're going to make you go this other step. Okay. And you want to write it in terms of one variable. And I'll show you what I mean when we get there. But you don't want to have more than one variable. You don't want to have X, Y, and Z if you have, three unknowns. Because then you have to have three equations in order to solve. You have to set up a system of equations. So we want to write all of these in terms of just one variable. Then you write the equation, solve it, and then make sure that your answer actually checks off. Make sure it actually answers the question that they are asking of you. And so all of that I'll make sure we understand before we leave. So let's look at another one. All right, so we have 40 less than 5 times a number is 52 less than the number. So just like before, there are keywords you want to look for that's going to help you establish setting up the problem. Less than in this context is subtraction. And we see less than right here, which is going to be subtraction force. So we got 40 less than 5 times the number. When it's set up that way, the 5 times the number, which is multiplication, 5 times x, that's going to go first, and 40 less than that will be 5x minus 40. So just like if you had 40 less than 100, how would you find that? You know that's 60, but the way you would do it is 100 minus 40. So 40 less than 100 would be 100 minus 40, which would be 60. And then is our equal sign. 52 less than the number, so it's going to be x minus 52. All right, questions? Any questions? All right, so we can go ahead and solve it. Subtract x from both sides. So that's 5x minus 40 equal to negative 52. Then we can add 40 both sides. And I didn't put 5, it should be 4x. 5x minus 1x is 4x. So now add 40 to both sides. 4x is equal to negative 12. And finish it off by dividing by 4. X is equal to negative 3. Any questions? All right, so consecutive integers. It's talking about negative 2, negative 1, 0, 1, 2, 3, and so on. If I wanted to, well, you know what? Let me do this. Before I do that, let's go here. Consecutive even integers. All right, so we're saying consecutive integers. We're talking about numbers back to each other. You only separate it by 1. 10, 11, 101, 102. Consecutive even integers, 2, 4, 6, 8, 22, 21, 22, 24. Even integers or even numbers back to back. And then consecutive odd integers or odd numbers back to back. Okay, so just want to make sure we understand when you see that terminology, what we mean by that. So let's see, how do I want to write this? Um, mm, all right, so consider try to make this like a chart so we could actually compare what you would do if they would have gave you a certain terminology. So if you had consecutive integers, so we're looking at the first one, consecutive integers. Um, the first number you would use is x, or the term or the thing you would use to represent your first number would be x. The second number would be x plus 1, right? If I have consecutive integers, if I want to go from 1 to 2, all I'm doing is adding 1 to it. Now, if I want to go from 1 to 3, I would be adding 2. And so that would be the pattern. So you do x plus 1, x plus 2, x plus 3, and so on. So that means once you solve for x, you can find the rest of your integers, whatever they're asking of you. If they ask for 3 consecutive integers, then you would use x plus 1, and x plus 2. All right. So now if they ask for consecutive even integers, looking at this category now, consecutive even integers, you always start off with x. But this time, if I go from 2 to 4, I need to add 2. And then if I want to go from 2 to 6, I need to add 4. So that would be the pattern that you would take on for consecutive even integers. So you go 2, 4, 6, 8, 10, and so on, but you would be adding 2, add 4, add 6, add 8. For the last column, if you're talking about consecutive odd integers, a lot of people make this mistake. If you look at what we got going on up here, if I go from 1 to 3, that would be 2. If I go from 3 to 5, that would be 2. So I'm actually adding 2 in the same way that I did your even integers. So it's not about the fact that it's even or odd that makes me add 2 versus 1. Is about how many space is between my two numbers. So to go from 1 to 3, I have to add 2 to it. To go from 3 to 5, I have to add 2 to it, and so on. So consecutive odd integers and consecutive even integers have the same space between their numbers. And so you'll use the same relationship. All right, so let's try to use that. We have 10 times the smallest of three consecutive integers is 22. More than 3 times the sum of the integers. Find the integers. Somebody said something. Yeah. Let me hold on. Look like I went black. Let me show something real quick. Okay. That's not right. Sorry, I'm still acting funky. All right, there we go. All right, somebody asked me to scroll up. Is this far enough, or how far do you want me to go? All right, so that gets up into this problem right here. Is this where you want me to stop?
Just a chart.
Oh, okay, right here.
Yeah, thank you.
Mm-hmm. All right, so we have 10 times the smallest of three consecutive integers is 22 more than 3 times the sum of the integers. Find the integers, so just need to take our time with setting this up. First of all, we have 3 consecutive integers. So we can call the first integer x, second integer x plus 1, third integer x plus 2. Remember, that's what we're looking at the chart. If they wanted a fourth integer, then we would have done x plus 3, x plus 4, and so on. You would just keep going on until, I'm pretty sure they're not asking that much of you. I'm just saying, just for future reference. So those are our 3 integers. It says 10 times the smallest of the 3 consecutive integers. So if you're talking about the smallest, that would be the x. So that's 10. And it says is, so that's the equal signs. 22 more than in this context is the addition. that's 3 times the sum of the integers. So that's addition as well. So we want to add them all up. So I need more room. Coming down here. So we're looking at 10x equal to 22 more than 3 times the sum of the integers. So you're talking about x plus 1 plus x plus 2. So I took all 3 of these and added them together. All right, so you said 3 times the sum. So that's 3 times adding them all together. So before we go any further, any problems or questions with the setup? All right, so what's going on here? All right, so let's go ahead and add these together, or simplify as much as we can inside of the parentheses. Combine your like terms. X is 3x. 1 plus 2 is 3. Distribute. So that's 9x plus 9. Combine these like terms of 22 and 9. It's 31. Then subtract 9x. X is equal to 31. So that's not the answer. If I'm not mistaken, it says find the integers. So we know x is equal to 31. X plus 1 would be 32. X plus 2 would be 33. So those would be your answers. All right. Questions. We got 2 more problems and then we will be done. 4, 7, we'll get done. All right, so let's do this. Since these last 2 problems are similar in setup or similar as far as the way they're presented, we can do these last 2 problems on next class. So we'll do these 2 problems because I didn't want to, we only got a few minutes left. So I didn't want to rush through them or maybe do one and not do the other. So we'll do these 2 problems on next class and do 10.8 as well. And then we'll be done with chapter 10 stuff. So before we close out today, questions, concerns, comments, anything, anybody? Good, straight. Okay. All right. So if you all are good, I am good. I will see you on Thursday and we'll close out chapter 10. You guys have a good one.